Hi students. In this session, we are going to discuss about power amplifier. We already know the application of transistor is a amplifier. What are the transistor we have discussed in this in the previous classes? BJT and FET. The application, well-known application of transistor is amplifier. What is the amplifier? What is the working of amplifier? It's a device to increase the strength of the weak signal. Okay, the amplifier is, if the amplifier classify the voltage, that is called a voltage amplifier. See, sorry, if the amplifier increase the voltage strength, then it is called a voltage amplifier. If it is increase the current of the given input signal, then that is called a current amplifier. Then if it increase the input signal power, that is called a power amplifier. In this class, in this session, we are going to discuss about the power amplifier. So the power, there are some classification under power amplifier. See, if you under amplifier, if you are boosting the voltage, that is called voltage amplifier. If it is boost the current, then it is current amplifier. If it boosts the power, that is power amplifier. We are going to discuss about power amplifier. So under power amplifier, so many classifications were there depending upon the many configuration. So but here we are going to discuss about classification of power amplifier based on Q point. So there are class A, class B, class AB, class C. So before going to the explanation, we should know about what is Q point in a amplifier, in a transistor. The Q point is a nothing but it's a transistor operating point. Transistor operating point. Q point is otherwise called transistor operating point without applying any input signal. Without applying input signal. It means that if you are applying a bias voltage, what is bias? You people know. The bias is a external voltage applied to the transistor to make the transistor working properly. That is called bias. So, while giving a bias to find the correct operating point of the transistor, that is called a Q point. Now we will see how we find the Q point in the transistor. We people well known about the different configuration and output characteristics of the different configuration. So we should take output characteristics. What is output characteristics? We should draw between output voltage and output current. Output voltage and output current. Output characteristics is drawn between output voltage and output current. This output characteristics belongs to common emitter configuration. So what is common emitter configuration? The emitter is common between input and output. So here only we will take output. Here we are giving input. So the emitter terminal is common between input and output. Okay. So here output voltage is VCE. VCE, output current is IC. This is the output characteristics of a common emitter amplifier. So to draw the load line, this red color line is called a load line, DC load line. It means that without giving any input signal, what is input? That alternative signal is input. This is a bias voltage. Without giving any input signal, we can draw the load line. That load line is called, this is a direct current voltage. This is called a DC load line. So we know that in a common emitter amplifier, whatever the amplifier, the general equation for the transistor is VCE equal to, that a drop across the output side equal to VCE equal to VCC, that at a bias voltage minus, if you are connecting a resistor, that is ICRC, the voltage drop across this resistor. This is a general equation of the transistor. VCE equal to VCC minus ICRC. To find the X crossing point, to know the VCE value, we make IC equal to 0 in this equation. If you are making IC equal to 0, it means we will get VCE equal to VCC. VCE equal to VCC. So that is considered as that this point. That is a crossing point. To get the Y crossing point, we apply BC equal to 0. We apply this one is equal to 0. What we will get? DCC equal to ICRC. So IC equal to VCC divided by RC. So that is VCC. That here they mean that load, RL means load resistance, or else it is connected with the collector. No, that is called RC, collector resistance. So after marking this point, we draw the line that is called DC load line. In this DC load line, it is a DC load. We will find the correct operating point of the transistor. So this is about the operating point of the transistor. Explanation about how we get the operating point of the transistor. So if the operating point in the active region, this is the active region. This region is called a active region. If the operating point, the active region, the transistor working properly. If it is in a cutoff region, this is the called cutoff region. If it is in a cutoff region, the working is somewhat, some application we need to work the transistor in a cutoff region. Some application we will, our transistor will work in a saturation region. Okay, if it is in an active region, it will, the working is the selection of the Q point is a correct one. This is about Q point. Next, we will move to the classification. What is the first classification? Class A. This is a simple diagram. If you are referring the internet and textbook, you people see different types of diagram. But for our syllabus, as a CSE student, we should know the simple diagram. The simple diagram is enough. For in an exam also, people can draw this diagram alone. No need to draw the complex diagram. After drawing the diagram, what is the working of this class A transistor? If you are giving the input waveform, we will get the amplified version of the input waveform. The shape and other things of the signal is similar with the output waveform shape and other frequency values. Everything is similar with the input waveform except the amplitude. Except the amplitude. Okay. Then the transistor working for the entire input signal. It means that it's starting from 0 degree, 90 degree, 180 degree, 270 degree, 360 degree. The transistor is on for entire 360 degree of the input. So it processes the entire input signal. That's why it needs some amount of power to process the signal. So it needs some amount of power to process the entire signal, and also it on during the entire input. So because of the entire input, it has the drawback of heating effect. It has a drawback of heating effect, and also it has a lower efficiency. Why it has a lower efficiency? Because it takes some amount of input power to process the entire input signal. That power is wasted during the processing. Only minimum amount of power we will get in the output side. What is efficiency? The amount of power we will get in the output side is called efficiency. Because of processing the entire input signal, we get a very minimum power in the output side. That's why it has a low efficiency. So what is the advantage of class A amplifier? It processes the entire input signal. What is the drawback of there is no distortion here. What is the drawback? Two advantages. It processes the entire input signal. There is no distortion. What is the drawback here? There is a heating effect because of the processing of the entire time. Full time it is in on condition, and it has a lower efficiency because of processing of the entire input signal. So that drawback is rectified in the class B amplifier. So we already said that, no, depending upon the Q point only, selection of the Q point only, the amplifier classes are we are classifying the amplifiers in the 4 categories. So for class A amplifier, we are taking the Q point in the middle of the active region. In the DC loyal, middle of the DC loyal, we are selecting the Q point. That amplifier, that transistor is acting as a class A amplifier. See that we are giving input signal. How we get the corresponding, because of this operating point here, during the value of increasing value of the input signal, here also we are increasing value of the voltage, like that. So we are getting, for positive signal we are getting positive signal, for negative we are getting negative signal. This is what we get this is the selection of operator. Class A amplifier, we are selecting the Q point in the middle of the DC load line and middle of the active region. This is about the class A amplifier Q point selection. Then the drawback of the class A amplifier is rectified in the class B amplifier. So I already told that a single transistor is processing the entire input waveform. That's why the efficiency is reduced. To increase the efficiency, we use two different transistors. One is NPN and other is PNP. So the positive waveform is the positive cycle of the input waveform is processed by the NPN transistor, and the negative cycle of the input waveform is processed by the PNP transistor. Okay, here also we will get some drawback. We are individually getting the positive half cycle and a negative half cycle. From switching from positive to negative, there is a distortion. I will see the diagram of distortion. So during the positive cycle, transistor 1 is in on condition. During the negative half cycle, there is a transistor 2 in on condition. So here, see here, actually what is the regular output? It is look like this only. But here there is some kind of distortion. This is called crossover distortion. This kind of distortion is introduced in the class B amplifier, but its efficiency is very high. When you are comparing the efficiency with the class A, its efficiency is very high. Because of the utilization of the two transistors for processing the separate half cycle. So here we are choosing the Q point at the cutoff region. We are choosing the Q point at cutoff region. So it is a single transistor working. So for a single transistor, we are choosing the Q point at the cutoff region. It processes only the positive half cycle. If it is an NPN transistor. If it is a PNP transistor, in the opposite polarity, it processes only negative half of the input signal. So now I hope you people get an idea about the class B amplifier. So what is the advantage here? Here advantage is the efficiency is compared with the A is very high here, but here the introduction of the crossover distortion. Next we are moving to the class AB amplifier. So to reduce the crossover distortion, we are moving to the class A amplifier. To reduce the crossover distortion, we are using this diode resistor combination to the transistor. This combination reduces the distortion. The same diagram, its diagram is similar to the class B amplifier, except the component diode and the transistor. Okay, because of the diode and transistor, this crossover distortion is reduced here, and also here the efficiency also increased when compared to the class B amplifier. See here we are choosing the Q point above the cutoff region. So above the x-axis, this is x-axis, this is y-axis. Just above the x-axis, we are choosing the Q point. So here only particular portion of the signal, particular portion of the input signal we are getting here. If you are using two transistors, whatever the input signal we are getting, we will process that and we will get. So this is about the selection of Q point in the class A amplifier. Depending upon the portion of the input we need, portion of the input we have to amplify, we will choose the type of the amplifier. If you want to, this is called clipping of some amount of frequencies from the input signal. If you want to clip some amount of frequencies, you can use class AB amplifier. So depending upon our need, we people use either class A, class B, class AB, or class C. Then class C, we are in a class C amplifier, we are using some tuned load circuit. This tuned load circuit will reduce this is a combined this tuned load circuit, which also reduce some kind of distortion. When compared to this load circuit select some amount of frequency, but here efficiency is very high. See here, efficiency is very high, but it sacrifices the amplification process. When comparing the other amplifier, this circuit is called tuned load circuit. This tuned load circuit increases the efficiency, but it is sacrificing the amplification process, and also it suppress some kind of frequencies in the inputs from the input. It suppress some range of frequency and allow the certain range of frequency. Depending upon the tuning of this load, we can choose which frequency we need to select in the output side. Okay, this is about the class C amplifier. Here the selection of Q point is below the x-axis. If you want to cut the portion of the signal, so class C amplifier, sacrificing the amplification process but increasing the efficiency. And if you want to choose some amount of frequency from the input signal, we people use the class A amplifier. So we will compare the 4 amplifier what we have studied. Class A amplifier working for the entire 360-degree input. Class B only 180-degree of the input. Class C less than 90-degree of the input signal. Class AB above, that is greater than 180-degree and less than 360-degree. Where is the position of the Q point for A? The Q point in the, for class A amplifier, the Q point is the center point of the load line. In the class B amplifier, it is exactly on the x-axis. For class C, it's below the x-axis. For class AB, it is between the x-axis and the center of the load line. Then what is the efficiency? When in a class A amplifier, the efficiency only 25 to 30%. But B, we are having 70 to 80% efficiency. But in C, greater than 80% efficiency we are getting. But in AB, it have the efficiency greater than A, but less than B. It should be in the range of 50 to 70%. If you are talking about the distortion level, in a class A, there is no distortion. But in a class B, crossover distortion. Class C, it's a large amount of distortion is there. But here, the efficiency is very high when compared to all other amplifier. And class AB, the distortion is very small amount only. Okay. I hope you people understand what is class A amplifier and class AB amplifier, and how we select the Q point for the particular amplifier and the comparison of all the amplifier.